All right, we are entering our last section of the year, 8.6, which is solving our rational equations and inequalities. So we're going to put together a lot of the different information that we have learned over the course of this chapter. So rational equation just has to have a rational expression in it, so a fraction in it. And we're going to also deal with inequalities today. So when we deal with these rational inequalities or rational expressions or equations, we need to first find out what is the common denominator, because all of these have addition and subtraction to deal with. And the suggestion would be to find a common denominator for both sides of the equations, all together, one single common denominator that would incorporate the whole thing. So in that case, when we look at the bottom of these fractions, I have 7, I have x minus 3, and I have 56. Remember, with 7 and 56, we need to use factor trees or some other method to find out a number that the smallest number that both of those can go into. So if you use factor trees, 56 would be 8 and 7, 2 and 4, 2 and 2. So 56 is representative of 2 times 2 times 2 times 7. And then, of course, 7 is as far as it can go, and x minus 3 is as far as it can go. So your LCD is equal to, which one has the most amount of 7s? Well, they've got an equal amount. The most amount of 2s, there's 3 of them, and the most amount of x minus 3s. This is the first time that we've really had a combination of something that uses factor trees and something that might need to be factored in the same kind of problem. So our LCD simplified would just be 56 times x minus 3. So that LCD has to be incorporated all the way across. So in this first denominator, I have a 7. That means that I need to multiply the top and the bottom of that by the 2 to the third times the x minus 3. So I have 4 sevenths, and I'm going to multiply it by 2 to the third, which is 8, times x minus 3 on top and bottom. The next denominator was 3 over x minus 3. So it had the x minus 3 already, but it doesn't have the 56. So we're going to multiply it by the 56 on top and bottom. And finally, 53 over 56. It already has the 56. It's missing the x minus 3. So each of these denominators I should be able to check and multiply them out, and they should all equal what my common denominator was. 56 times x minus 3, 56 times x minus 3, and 7 times 8 is 56 times x minus 3. So I know that I've done this part right. So let's go ahead and start simplifying. I have 8 times 4, which is 32, times x minus 3, plus 3 times 56, which is 168. And then 53 can be distributed into here. It's a 53x minus 53 times 3 is 159. And this whole denominator becomes 56 times x minus 3. This whole denominator becomes 56 times x minus 3. This looks a whole lot now like a proportion. A fraction equals a fraction. And if I wanted to get rid of the fractions, I would multiply by the denominators. Remember cross multiplication? 56 times x minus 3 times 56 times x minus 3. That cancels out my denominators. That leaves me with just whatever was up top. Now we did that on purpose. That's going to help us skip some steps in the coming problems, because if you find the common denominator for all three parts and you multiply it out for the common denominator for all three parts, you can ignore the denominators completely because they will always cancel out. So all that we are left with is this 32 distributed. So we have 32x minus 96 plus 168 equals 53 minus 159, which is a really simple equation that we've been solving since Algebra 1. So I'm going to give you a minute. Go ahead and complete solving this equation. I'm going to show you my steps so that you can check to make sure that you've done it right. So you should have gotten that x equals 11. And you can plug that in and make sure that it's right. The hardest part of this whole problem is that LCD process. So let's do it again with problem B. We're going to find the LCD. And when I look at this, I see that 2 doesn't have a denominator. So it's really over 1, which makes our lives pretty simple when we're finding the LCD. All of the denominators are factored as far as they can. So my LCD is just 3 and 2x plus 1. So when I look at the first fraction, it already has the 2x plus 1, but it does not have the 3. Now remember, we said that if we found the LCD for all three of them, I can ignore the denominators. I recommend that you at least double check that we're doing it right by multiplying, make sure that, yes, that is the common denominator, but you don't have to write them like we did over on this other problem, because every single time they will all go away. So we're just focusing on the numerators. So the second one, it already has the 3, but it doesn't have the 2x plus 1. So I have 4 times 2x plus 1. And then the last denominator, it doesn't have any of my common denominator. So we got to multiply the whole thing out. 3, 2x plus 1. 3, 2x plus 1. And we're focusing only on the numerator. So 2 times 3 is 6 times 2x plus 1. So 3 times 10 is 30. Distribute your 4 inside. So I have 8x plus 4. Distribute the 6 inside. So I have 12x plus 6. So I'm going to give you a moment. Go ahead and finish solving this equation out. I'm going to show my steps so that you can check your answers. So we get that x is equal to 7. Take a look at C. Now I notice that all of my denominators are not completely factored, so I do need to factor this last denominator. Go ahead and pause the video, work through your factoring steps to make sure that you're factoring this correctly. So I have x plus 3 and x minus 2 as my factors. So when I go to set up my LCD, I have the most amount of x plus 3's is just 1. The most amount of x minus 2's is just 1. So my LCD is x plus 3 and x minus 2. So when I go to find what these denominators need to become common, I notice that the first one already has an x plus 3, so it needs an x minus 2. So I'm going to focus only on the numerator. 14 times x minus 2. The next denominator was missing an x minus 3. Sorry, an x plus 3. So I'm going to focus only on the numerator, 10 times x plus 3. And then the final denominator isn't missing anything, so I can leave it as just 122. Pause the video and finish solving out this problem and see if you get the same answer. You should have gotten that x equals 5. We're going to do one more equation before we jump into inequalities. So for D, I notice that the x squared minus 4 has not been factored out. So I need to factor it out to be x plus 2 and x minus 2. Remember, it follows that pattern. 2 perfect squares with the minus in the middle. And for my LCD, the most amount of x plus 2's any one of them has is just 1. The most amount of x minus 2's that either of them have is just 1. So my LCD is just x plus 2 and x minus 2. The first denominator already has an x plus 2, but it needs an x minus 2. So I have 5 times x minus 2, because we focus only on the numerators with equations, minus the second equation has x minus 2, but it needs an x plus 2. So minus 3 times x plus 2. And the final denominator doesn't need either the x plus 2 or the x minus 2. So it just remains as 12. Before you pause this video to solve this, I just want to make you remember you're going to be distributing a negative 3 all the way across. So pause the video and see if you get the same answer as I do. you should have gotten that x equals 14. Now, let's take a look now at inequalities. So for the inequalities, the first thing that you need to consider is the fact that there's a range of numbers that are included in here, not just one single number like with equations. So we have to first find out what would make the denominators equal to 0. So in this case, I have that the denominator would be 0 if x was equal to 0. So that's a key point that we're going to have to find later. Now you're going to solve the inequality just as if it was an equation. So we need a common denominator. So that means I'm going to have 30 is the smallest number that all of them can go into, and each of them has only one x. Remember, you can get that from your factor trees. So what does the 5 need to become 30? It needs a 6, and it already has the x. What does the 6 need to become 30? It needs a 5, and it already has the x. What does the 3 need to become 30? It needs a 10, and it needs the x as well. Focus only on the numerators. 6 times 3, 18, plus 5 times 1, 5, equals 20x. So 23 equals 20x. Divide both sides by 20, and we get that x is equal to 1.15. Now, remember, we said that this was going to become an important part. Well, that's because this inequality has two key parts. We have a key part at 1.15, a key part at 0. That divides our number line into 3 separate parts. One here, below 0, in between 0 and 1.5, and greater than 1.15. So pick a number for all 3 of those parts and plug it into the equation. So below 0 would be -1, between 1 and 0 could be 1, and greater than 1.15 would be 2. You want to pick nice and easy numbers to plug into the original inequality. So I'm going to plug in -1 first. So I have 3 over 5 times -1 plus 1 over 6 times -1 is greater than 2/3. And we want to see if this equals a true statement or not. So when I do that in my calculator, I'm going to do 3 over -5 plus 1 over -6. That's the 5 times -1 and 6 times -1. And I get -0.77 is greater than 2 divided by 3 is 0.6 repeating. And that's not a true statement. So because that's not a true statement, that means that anything below 0 would not work in this inequality. So we try something in between them. We're going to plug 1 in for x. So 3 over 5 plus 1 over 6 gives me 0.77 is greater than 0.6 repeating. Sorry, I didn't realize you couldn't see that. So 0.77 is bigger than 0.6 repeating. So that's a true statement. So that means everything in between here does work. And finally, we need to try something in the last portion. So 3 over 5 times 2 plus 1 over 6 times 2 is greater than 2/3. When I plug that into my calculator, I get 0.38 is greater than 0.6 repeating. That is not a true statement, so that means nothing over here can work. So the only things that can work are things between 0 and 1.15. So we use can't equal 0 because it would make the denominator equal to an undefined number or undefined. So that would be an open dot. And this is not equal to 0, so it's also an open dot. So the inequality that represents all the numbers between here is 0 is less than x is less than 1.15. Last inequality here. So we need to first find out what can x not be, or what can y in this case not be. And we decided that it can't be what's going to make it equal to 0 on the bottom. And that would be 0. If y was 0, it would give me a 0 in the denominator, which is undefined. Now we're going to solve the inequality as if it was an equation. So I have 4 over 3y plus 2 over 5y equals 3 over 3 is really just 1. So we need to find a common denominator, your LCD. LCD in this case is 15y. So I'm going to have the 3y already has, what does the 3 need to become 15? It needs a 5, and it already has a y. What does the 5 need to become 15? It needs a 3, and it already has a y. And what does the denominator of 1 need to become 15y? It needs both 15 and y. Focus only on the numerators. So we have 20 plus 6, that's 5 times 4, 3 times 2, equal to 15y. 20 plus 6 gives me 26. Divide both sides by 15. And it doesn't come out nicely. It's 1.73 repeating. So I can set up my number line. 0 is an important point. 1.73 repeating is an important point. So I need to pick a number in all 3 sections that this separates it into. So once again, -1 is below 0. 1 happens between 1.73 and 0. And 2 happens above it. So we're going to plug our numbers, or those values in to the original inequality and see which one works. So I have 4 over 3 times negative 1 plus 2 over 5 times negative 1 is less than 1. So 4 over negative 3 plus 2 over negative 5, and we get negative 1.73 repeating is less than 1. That's a true statement. So everything below 0 would work. Let's plug in 1. So 3 times 1 on the bottom and 5 times 1 on the second fraction. So I have 4 divided by 3 plus 2 divided by 5 gives me 1.73 repeating is less than 1, which is not a true statement. So nothing in between works. And finally, we're going to plug in 2. So I have 4 over 6 plus 2 over 10. And I get 0.86 repeating is smaller than 1. And that's true. So that means everything above it will work. So the original problem did not have an equal to. So my 1.73 should not have an equal to. It should be open. And it can't equal 0. So it should be open. So the inequality that represents this is y is less than 0 and y is greater than 1.73 repeating.